So I think we are covering the networking side of AWS components, and in that just to recap, we looked at what are AWS regions and availability zones. Uh, yeah, uh, and yeah, we know what are the region is a geographical location, whereas availability zone is a data center within the geographical location. We looked at what are the considerations for a region. Then we looked at VPC, which is one of the popular motherhood of the networking. So nothing but a VPC is a virtual private cloud. Yeah, it primarily helps you to bring an isolated virtual network in AWS. And we saw some use cases under VPC. And we looked at the scope of VPC, which is by default extending to across availability zones. Um, so whereas where you have a requirement where this VPCs will extend across to availability zones, but the subnets are within the range of availability zones. We saw that, and then we also looked at we don't want to do the complex setup of VPC, or we don't have custom VPC requirement for small POCs. We want to make it very simple. Then default VPC options are available in AWS where you can go with the default options. Then the high-level VPC components we saw: subnet, route table, internet gateway, NAT gateway, VPC endpoint. So I think just for recap, so subnet is public subnet, private subnet. These are the two categories under subnet. Route table is where it's something like a firewall, where you create all the rules for the routes, where you give directions in how the networking traffic should be moving from one place to other. And also we saw networking internet gateway, which provides internet. NAT gateway, again, temporarily allowing an internet to a private subnet. Generally, private subnets will not have access to internet, but the scenarios we discussed where so your database is in a private subnet where there's no internet. So, but temporarily you want to do a patch upgrade of the database in the private subnet. Then you need a temporary internet access. That's where NAT gateway will play a role. Then VPC endpoints we saw, which is primarily privately connecting your VPC or to other AWS services also. So that's where VPC endpoints. They all primarily use private link, which is a private link is a concept where you don't need internet, and all the communications can happen without internet. So security aspect. So VPC endpoint is a tooling. So we saw about the basics about how this networking CADR notations will play IPv4 and IPv6. We understood what is we had gone through the various ranges, like slash 16 means what, slash 24 means what, slash 28 means what. So and also we also discussed about the AWS reservations, where the first five IPs, I mean the five IPs will be reserved for AWS, even though we get a subnet of, for example, in this case you get 4096 IPs, but out of which five IPs will be reserved by AWS. For example, 0 to 3 and the last one. The first four and the last one generally is reserved for AWS. The rest of it definitely can be used for your project purposes. Then we saw internal IP addresses. So VPC range under that subnet. So a bigger room you're splitting into smaller rooms. But yeah, your instances, EC2 instances should be within that broader range of the VPC IP that you're assigning. So, so your subnets under that your instances or other AWS resources will be using the range within that subnet. So, for example, yeah, in the subnet was 04 to 254. So your instances can EC2 instances can have the IPs within this range. Similarly, this is a different subnet. Yeah, so you can have your instances should have IPs within this range only. But yeah, broaderly is connected by the VPC range on the outer layer. Then also we discussed about IPv6. Then internet gateway. So yeah, I think this primarily to provide internet. And we also discussed about the security aspects within the networking layer, which is security groups and NACLs. Security groups primarily to get to bring the traffic. I mean, to control the traffic at instance level. So where you can apply security at instance level, but whereas the NACLs the network access control list, they provide the security at a networking level or subnet level. Whether you can access or deny the rules based on the traffic that is coming at network level, whereas security groups are within one level lower, where you can do the the restrictions at a EC2 level, instance levels. Then we saw the differences between security group and NACLs. Again, very important topic from exam point of view. Where the security groups, as we discussed, is at instance level, NACL is at subnet level. Security groups are stateful and snackers are stateless. They only allow operation, but here you get both allow and deny. The rules are all rules are evaluated, no order. There's no order of rules. If there are 10 rules are there, there's no order in the rules. All are equal priority. But whereas in knackers, you have an order. I mean, if there is order, then the lower numbers get the highest priority. While executing the rules, 10 rules, the lower number rule will be given higher preference. Then from this is separate instance level, and this is snackers are not at instance level. Again, it's first layer of defense, and this is snackers are the second layer of defense. Right, and then we saw NAT gateway. So this NAT gateway is again to temporarily allow the private subnets to have internet. So that's where in this architecture, basically you create a NAT gateway in a public subnet. Let's say your database servers are in a private subnet, and they want to temporarily get access to internet. So they create NAT. We create NAT gateway in public subnet, and so that way they can communicate via public NAT gateway, and they get internet temporarily. In this, only it is very simple configuration where you need to create a NAT gateway in AWS, and then in the root of this private subnet, you just need to tell the target as NAT gateway, so that way all the traffics coming from outside world, the 0.0.0 is like all public, all external traffic should go via NAT gateway. That is what we are defining here. So with that, the database servers will get access to internet. Sorry, I'm just going fast. I think if we have, I think there are also more topics. I think I'm just quickly going through. If you have any questions, you can stop me. VPC peering. So this, we saw that imagine a scenario where multiple VPCs, they want to talk to each other, because it's not typically possible, because it is a different network and it is a different network. But let's say there is a requirement where an EC2 instance in one VPC want to talk to a VPC, EC2 instance in another VPC, for whatever be the reason. So in that case, it is typically not allowed. So, but there is a very common use case where your company grows, and naturally you form new VPCs over a period of time. So, but you want the instances between two VPCs want to talk to each other for some reason. Then that's where the VPC peering will come into picture. Just just remember this VPC peering, because we'll be using in the today's concepts as well. So just recap is primarily just we will touch upon the same VPC peering in the VPN as well. So I want to just spend more time here. So this VPC peering will help you to connect two different VPCs to talk to each other. So typically, the VPC peering will there'll be owner who will accept, who will request for the communication, and there will be owner on the VPC B side who will accept that communication. That's when this VPC peering will become active, so that the data transfer can happen. So there are possible, there are a lot of configurations that are possible. Generally, this hub and spoke model, which is also called a star configuration, where two VPCs want to talk to each other. Typically this, so between two VPCs, it is allowed. For example, A to B, A to C. So, but there's no transfer peering allowed. So, like for example, it's not implied that B to C is connected because of AB and AC. So, transfer is not allowed. So, again, this is one of the drawbacks in peering, but which I think will be addressed in other VPN and other aspects which we're going to cover today. And then whatever bit is the overlapping of CIDR, the IP addresses are important here. So as we saw, there's a requester who will reject, and on the other side there will be an acceptor who will accept it. Sorry, was there a question?
Office వాళ్ళకి నాకు
Lakshmi, do you have a question? Hello.
Shyam, this is Niranjan. Okay, just a basic question. Different VPCs is for different AWS accounts, is it?
It can be in the same region, or it
Or
could be even a different
projects or
region also.
different region. So
Yeah,
for different in the same company, we can have for different projects as well, right?
exactly,
Different VPCs
exactly.
or not?
Yeah, it
We
is
can.
in the same project. We can have multiple VPCs also. Uh, so it is it can be at any level. So within the same project, or
Okay.
like same account, or it could
Same
be
account.
same
Okay.
account, or it could be a different AWS account. Uh, Again, it could be same region, or it could be different region. So various combinations can come
Okay.
where this
Okay.
VPCs are there.
Okay. Okay. So my doubt is, in a single VPC, can we have multiple instances, EC2 instances?
Yeah, that is possible. So yeah,
Okay.
you can have multiple EC2 instances under subnet. So yeah, it is very common. Yeah, I mean, you saw, if you remember that the previous slides here, for example, yeah, this, for example, you can have multiple instances under this subnet range,
Subnet.
right?
Okay.
For example, in this range, you have, let's say, 256 IPs are there. So all these 256 IPs can be one instance, well, one EC2 instance, like. So it can use all the IPs. For example, every EC2 instance can have one IP, right? But yeah, you can have n number of EC2 instances under the subnet range covering these IPs. Yeah,
Okay.
there's no limitation on the how many EC2 instances can be there in the subnet.
Okay.
As long as IPs are available, so you can assign. So yeah,
Okay.
so right. So yeah, so basically, yeah, this is a requirement where an EC2 instance or the multiple EC2 instances, for example, in one VPC A, want to talk to EC2 instance on other VPC. So, but generally the VPC is an isolated boundary of networking, right? So you can't. Typically, this is not allowed unless you need to have some alternate options. Alternate options. One of the alternate option is VPC pairing. So you can enable peering connection between these two VPCs. So that way, so these both are connected, and so yeah, in that case, these both can talk to each other. Right. So yeah, that's what this VPC peering. If you look at it, will allow traffic between two VPCs. Either the two VPCs can be different regions. That's where it's called inter-region VPC pairing. Because this VPC A can be in US, and this VPC B can be in India, for example. So they both they're in different regions. Then they can still connect via VPC pairing. And then our other thing alternative is this VPC A is in one account, and AWS account, and VPC B is in a different AWS account. So in that case also, peering will help you to make this connection happen. Okay, so yeah, very important thing is this transitive peering is not allowed.
What's the transit peering you mean in this case, Shyam?
Yeah, transitive peering is what I mean is, like, for example, if A and B are connected, VPC and VPC B are connected, okay, and similarly A and C are connected via another VPC pairing. So it is not implicit that B and C are by default connected. They are not connected. So you need to form one more connection between these two. I mean, one more VPC pairing should be there between these two. So that's what I mean by transitive. So AB, like, yeah, AB, AC, then it's not, BC is not implied.
Okay, understood.
Yeah.
Thank you. That's a good one. I think yeah. Otherwise, it's a security loophole.
Exactly. Yeah.
Okay.
Yep. So yeah. So other we discussed about other complex scenario where you have a requirement where I mean, so far all whatever we saw here all are inside AWS. But imagine a scenario, very common enterprise scenario where a cloud wants to talk to a data center, on-premise data center. So that's where one such option is direct connect. Um, so so on the right hand side you have a data center on-premise customer environment. And on the left hand side, you have complete the AWS cloud, public cloud, and now you want both of them to talk to each other, uh, and over a private line. That is a very important keyword. So over a private line, which means no internet. So without internet, you want, for security reasons again, you want your on-premise data center. Either it could be it could be an application here, or it could be a person who is trying to connect to cloud. So it can be anything for that matter. So any connection going out of your on-premise in a form of data or in a form of data transfer, it could be in a form of application talking to other application cloud. So it could be anything. So yeah, any connection going out of your network. Um, and it should be for some reason, for security reasons and other reasons, we want to make it private, meaning no internet. Then so in that case, one option is direct connect. So this is nothing but it requires an intervention of a third party customer, which primarily an AWS partner uh, should come in place in between. So for example, there will be a lot of AWS has a lot of partners who provide this direct connection. There are a lot of vendors who support this direct connection in various geographies. They have tie-ups with multiple partners across the globe. AWS has partners, so we have to rely on this third-party person to provide this direct connection to AWS without internet. So which means the typical network would be, on the customer side, you'll have a router or a firewall which will be configured to a customer or partner cage, where you have there will be a router configured on this side as well, where you will have a tie-up with the vendor, and then you form this network on the customer side. Same thing on the this this connection will be there with the help of the vendor. There will be connection from AWS to this vendor's location, AWS cage. It's called AWS cage, but even though it is a customer's, I mean the third-party customer's the networking connection. So basically, your third-party guy cage and your cage, I mean your on-premise cage, they both are connected via LAN, and then you transfer the data across. So typically, the options that you have are like 1 Gbps and 10 Gbps connection speeds. These are two options that we have. And generally this is very fast, and the networking costs can be drastically reduced in the scenario where, because you don't have internet. So I mean, it's not going via internet. So the internet, if it is going via internet, we can't say when the bandwidth is up or when the bandwidth is slow. So because it is shared by multiple people, but here it is all yours only. So yeah, your own network and your own consumption only. So that way, you know what is the ups and downs, and closely monitor, and generally it will drastically reduce the networking costs. Uh, the very common use cases that we saw is typically the one-time data migration that, let's say, you want to do to transfer your on-premise systems to cloud. And let's say you're talking about the huge data that you want to shift to a database, for example, on AWS, or a big data which you want to shift from your customer network to a cloud. We're talking about the cloud migration. So in that initial phases of the cloud migration, you need to transfer a lot of data over the network. So that is a very common use case for direct connect, where you have where yeah, that's one use case. And then also we're talking about the real-time data feeds of a voice or a video feed. Generally the voice or video feeds are like pretty data intensive. So that is, if you have a if your use case is like you're dealing with such kind of real-time voice and video feeds, then so you need to have your own bandwidth. So you don't have to rely on your uh, ISV vendor who's providing internet. You don't have to rely on that. So then in that case, that's one very common use case. And also for say regulatory requirements, you want to use your own private connectivity. That's another use case where this direct connect will play a major role. I think we also saw that how this direct connect works. Like the flow is, um, yeah, in AWS, you will decide on what should be a direct connection location and as a connection size. Um, we saw that not all locations are having this option because we are relying on this third party vendor here to provide this. So yeah, for example, in Chennai, we saw, for example, there's only one vendor who supports this. So likewise, yeah, it depends on the region and whether the vendor is there in that region or not. So it depends on that. But generally, there are at least minimum one vendor available mostly, and the count is increasing every day. But yeah, but at least that is one drawback on this side where you have to rely on a third party vendor here in between. So anyway, so that once you know for your location there is a vendor who is providing this support. So yeah, you select the location and you also select the connection size as a 1 GB or 10 GB. Once you have that connection, then you'll create your connection request from AWS console, and then you also give a letter of authorization from which you'll download from the AWS. So with this, AWS side of the work is done. So now it is up. Now it is a handshake between you and the third party partner or the APN partner. So using this letter of authorization, you start a conversation with the third party vendor, and then you establish the connection, and then yeah, and then you configure. Once you do, he will also do form this cage, and then he give all the details to you. So that you need to configure again in a AWS console. So that's how this connection is established. But typically this all takes some time, so it's all not very instant. So it will take at least depends on the vendor and other aspects. But yeah, generally typically it takes minimum 1 month to have all this process completed. But yeah, but it will take some time. But that's one of the drawback is direct connect. But yeah, that's how it is. Yeah. So so that's one use case where we saw an on-premise network want to talk to a cloud on a private network, and the other option is like VPC endpoint. This use case is where this is a very common use case where you already defined your VPC and there is some product EC2 or Glue or any other product for that matter. It wants to talk to another AWS product which is not inside this VPC but outside this VPC. So in that case, so typically what you go is if you don't have this VPC endpoint, the other way of is you should go out of internet and then over the internet you should come out and then talk to S3 for example. S3 is another product of AWS. So two AWS products, both are in the data centers of AWS, but just that this guy is within the boundary of VPC, he can't talk to this guy directly. So he has to go via public internet and come back. For example, there'll be some SDKs using some SDK. You AWS SDKs, you will generate write some code and then push some files to S3, and they all will go via internet and come and store in the storage, for example. So yeah, but that's a long route and it's going over internet, so which is again riskier from security aspect. So just to overcome that, we have something called VPC endpoint, where you can just tell or configure this VPC endpoint location. So that's also so it will not go outside the network. It will go directly go to the VPC endpoint, and here you have directions to tell if the request is coming from this VPC range, allow. So that kind of a rule that we will define here. So that way this guy will directly can talk to S3. So again, this is again privately connected, very important from exam point of VPC endpoints are privately connected stuff, not public internet. And yeah, again, there are two combinations here. We saw this interface endpoints and gateway endpoints. And also this, yeah, generally the advantage of VPC endpoint is you can straight away tell that you don't need to have an internet gateway because, again, if the assuming it's not there, you need to go via internet. So then you need to have an internet gateway on the VPC. So that can be avoided. NAT can be avoided. VPN connection is not required. Direct connection is not required. So yeah. So all these things can be eliminated with this VPC endpoint route. Yep. So yeah, and we saw that there are two combinations here, two types: interface endpoints and gateway endpoints. Again, very important from exam point of view. So they give you a scenario and then say which endpoint will be used. The difference between VPC endpoint the interface endpoints and gateway endpoints are interface endpoints primarily they use elastic network interface to connect. So if you look at here, they use the private subnet. They use internet elastic internet network interface, and they are talking to outside product or S3 or Kinesis. So they're talking using that, and they are using private link as private link is a very common terminology used in multiple products within AWS, where this is primarily giving a private access, not the public access. So that is again, it eliminates all this internet gateway stuff and all. But very important thing is interface endpoints. They support many AWS services. The list is growing. It's not that all products of AWS can talk via VPC endpoint. Every day a new product is getting the support is added to VPC endpoint, but not all products are added there yet. But very commonly most products are there at this point. Whereas this gateway endpoint is primarily they're free, so which means it comes with limitations. So it is like only two services are supported, S3 and DynamoDB. Let's say your target destination of another AWS product where you want to talk is S3 or DynamoDB. DynamoDB is a database. From AWS side, S3 is a storage. I think we'll cover in the following sections. But these are the two products, AWS products. If you want to talk to, then gateway endpoints will be a cheaper option because they are free. But whereas your VPC and interface endpoints comes with a cost. I mean, there will be usage cost for that. But whereas gateway endpoints are free. So yeah, in that case, if your requirement is you want to talk to S3 or DynamoDB only, then gateway endpoint is the option for you. Again, this gateway endpoints goes with the router approach, where you just create a gateway endpoint and then you just make an entry in a route table. So that's all. So your S3 endpoint and you connect with your VPC gateway endpoint ID. So with that, if you just make this entry in the route table, then you're good. So that's how this gateway endpoint works. Yeah, and then also in the last session we saw about the VPC flow logs. So primarily for it's nothing as it's not a product as such, but I mean it is a debugging tool inside VPC where you want to there will be a cloud engineer who wants to do some debugging on how the flow goes across, and you want to debug how the data is transferring inside and outside of AWS. Then this is a tool which will help a cloud engineer to resolve the flows. Um, so VPC. Sorry about that. Sorry about that. So VPC flow logs are primarily help you to resolve that. So it will help you to capture the IP traffic in and out of the network interface. Generally, the flow logs can be created at various levels: VPC level, subnet level, and network interface level. So these are the three areas where you generally create a VPC flow log, where it can monitor your incoming traffic and outgoing traffic, and it can push it for monitoring purpose. You need to store this log somewhere. So the most commonly used products are CloudWatch logs and S3. So S3 is coming again and again. So S3 is very important product from AWS, I think, which we'll cover when we come to the storage side of it. So yeah, so CloudWatch is primarily a monitoring tool in the category of monitoring and security. So CloudWatch is a tool where it can monitor all the logs. So yeah, so basically the summary is that this flow logs can transfer all the information about the traffic to these places, so that it will help you to diagnose primarily the connectivity issues within your VPC, or intrusion detection or anomaly detection. So all these things can be diagnosed using this flow logs component. So typical structure of your flow log, we saw that you saw your it's a log file at the end, right? It's just a log file. So log file is will have this structure, like space as a delimiter. So for example, version, your AWS account ID and your interface ID, the network interface ID, your source address, destination address, where the data is where the data traffic is happening from, so which IP to which IP, and your source port and destination port and protocol, packets, bytes. So start and yeah, this is a typical structure where you'll see a flow log. From this, you can, if there is any data that is not getting transferred for some reason, so that will be definitely logged here, so which cloud engineer can debug and find them. So this also we saw in the last session. Okay, so with that, I think it is just a quick summary of what we saw so far. I think today's session is on VPN. So VPN is I think most of us would have used VPN in some way or other, where we know the typical use case where you're we're talking about scenario where a cloud and there is a on-premise system. So generally, if they want to talk to each other, so we typically use VPN, right? So but AWS also supports that VPN feature, where we're talking about two VPN connections here. One is on the left hand side we have clouds, the AWS cloud, but I think most of us would have used this part of VPN in our day-to-day life, where as an end user you have some open VPN client, and you'll have an endpoint where you connect to that endpoint, and with which you will be connected to an on-premise network, right? For example, if you're using based on whatever your client network is, so your on-premise, imagine there's an on-premise network setup, so you'll be connected to your on-premise network. So with VPN. So this is very common use case typically we do. But yeah, the same thing you can imagine for the destination as your cloud. So for some reason you want the connection to be secured, and from your on-premise you want to talk to a cloud for security reasons via a VPN endpoint. So then this is very common scenario that we use.
Yeah, Sham,
Yeah.
one question.
Yeah.
So by default, I think all the connections isn't it encrypted already, right?
Yeah.
So what is the need for a VPN especially, right? Like if it is encrypted,
Oh no,
what's the need for?
yeah, all are not encrypted. I mean, encrypted is you're transferring data via network, but the encryption is you have to enable or disable it. It is not by default enabled in all the data transfer. I mean, that's why in storage you have data at rest and data encryption at rest level when the data is in rest, and encryption while the data is in transit. So you have in most of the products you have both these combinations, but unless you enable it, they are not enabled by default. So for example, if you take S3 or anything for the example, they are not by default enabled or encrypted. So you have to enable it. But the point is not just the encryption. The scenario that we're talking about is the your on-premise network, and you are okay. Anyway, I need to put this boundary here. So you're an on-premise customer environment, and let's say your laptop in that case. So you're from your office connected network. So you want via VPN you want to connect, and with that you want to connect privately. That is very important. So privately or a secure channel you want to transfer, and you want to encrypt all the data transfer by default. So then that's where your VPN plays a major role there. And it's very important thing is it is
So the typical, Sham, the typical example is once you go to the office, right, and you are in the office network, LAN network, and if anything, you are trying to connect to the public subnet, there are ways to connect through the internet. But if there is a way to connect to the private subnet from your office network directly, for example, your business users or database users, they are power users, right? So they know how to do SQL query and they want to see if they are trying to see the patterns happening, blah, blah, blah. So you cannot ask them to connect to the public VPN, public VPC, then from public VPC tunnel through the private VPC, blah. That those things are all available, but it is not practical, right? So once the cloud is becoming as a second nature, you should be able to access the private nature of the cloud in a very secure manner. That's where the VPN comes into picture. You understand, Yanesh?
That makes sense. Yeah. So what happens is like you want to from one office to the other office, you want to directly go into their private network,
Private
and
VPC
you want to have a
directly.
secure
Yeah,
connection,
yeah.
right? That
As
makes
if
sense.
your data
Yeah.
center.
Yeah. Yeah. That makes
it is
that
something
makes
like
sense.
your extended data center. Imagine that
Yeah.
cloud is your extended data center. So and then you want to connect to your external data center for some reason. So yeah, so that's where your VPN plays a major role. And I think the use case, based on the use case, we have two options there. So one is an end user trying to connect. That's where the second option, like AWS client VPN, is what is required. But imagine this scenario is like it's called site-to-site VPN, where you want your data center, but you want to have an extended data center, another site you want to form, and imagine the resources, but the resource you are taking from cloud, but it is your extended data center. So if that is your requirement, then that's when this between two sites. So you want to form a connection, then that's where VPN connection, site-to-site VPN connection is important. So there's a very common. I think the use case are coming in the next slide. You will understand. But yeah, but just important from exam point of view that you need to remember is that this site-to-site generally is the use case is your on both sides there are data centers. So, but whereas in client VPN, so from the name itself, you can say it's client, right? So typically called by some end user. So end user will via client he will connect. So and he will connect to public cloud. So these are the two use cases. So there are separate. This requires a lot of work in terms of because you're talking about creating your own virtual private gateway on the cloud side, and you have a customer gateway on the customer side, and both should be privately connected via security tunnel, and then you need to do the data transfer. For example, you need an EC2 machine, extra EC2 machine or compute on your customer gateway. So imagine that this is now your extended data center. So you can cloud is your extended data center. So you can directly go and get a EC2 machine from here, and you can connect directly from your network. So via VPN. So this is very common use case, but it from infrastructure point of view, but this involves a lot of work. But yeah, this is on this side. The client VPN is like it's an open VPN client, so which means you can use any VPN client here. It's not just AWS also has its own, but you can use any popular open VPN clients available. So AWS supports most of them. So yeah, so an end user is on the one side trying to connect. So that's the difference from exam point of view. You need to remember. I mean, the questions will be around this, like end user I want to connect privately to the virtual private cloud. So what options you have? One is like VPN. So um, right. So and then here, if you look at so in both cases, your the tunnel that is forming is like a private tunnel. So which is again you don't have access to internet. So yeah, the data will go securely over internet without internet, and yeah, so with which you can connect. And here, this on this side, typically it could be a VPC, or there's something called transit gateway, which we're going to see in the following next topic. Is that so either on the AWS side for a VPN connection, on the one side is your customer gateway, and the other side is your virtual private gateway. But this virtual private gateway internally talks to either a VPC or a transit gateway, which we'll see next. What is transit gateway? So, but a very common is VPC. So, so basically VPC, virtual private gateway, these two are required on the Amazon side, and on the customer side, you need to have a customer gateway. So then, yeah, these both can talk to each other, right? So, right. So the next one is let's go more about this VPN site-to-site scenario. Just that this is a horizontal diagram, but imagine this is slightly upside down. It is made upside down. So this is a AWS network, and this is the customer network. So what is happening here is the same diagram where we have a VPC the subnet. VPC is here on here virtual private gateway and customer gateway. Both are there. So the site-to-site has primarily two VPN tunnels that will be created. So this two VPN tunnels is primarily for disaster recovery purposes. I mean, just in case redundancy aspect, if one goes on, other is always there as a backup. So typically one tunnel will be primary, other one will be secondary. So yeah, so if the primary goes down, then automatically secondary will become primary. So that is the concept. Um, so that's why it is like whenever you say site to site, two VPN tunnels is your the point that should come to your mind from exam point of view. There will be always two VPN tunnels that will be there. Again, that is all again for one VPN connection. That is, so you can have multiple VPN connections, but for one VPN connection there will be always two VPN tunnels. So typically, and all the data transfer it happens via IPsec. IPsec typically supports a lot of algorithms like encryption algorithms, AES 256 and SHA-2 and a lot of other algorithms are also supported. So again, it's all from security angle where the data is secured while going across, so encrypted on both sides. The data from, let's say, if I want to push some data from your on-premise to cloud, so typically you encrypt the data here, and the data will transfer over to the cloud, and the other way around as well.
So Sham, what is the significance of two tunnels actually? Right. So one is for
Backup, primary, secondary.
secondary. Oh, okay.
Yeah, primary, secondary. Yeah.
Okay.
So again, as I said, like two tunnels are added for redundancy. In case one is down, the other should work fine. So that is the redundancy aspect. And another thing is this is fully managed by AWS. So which means the software on this VPN and the management of the data transfer and the security and encryption, all those things are managed by AWS for us. So that is, but they'll be charged per hour VPN connection usage. So per hour there will be charges. But yeah, but otherwise, yeah, it is all fully managed. The software itself is fully managed by AWS. You don't have to bother about the versioning, patch upgrade, and all those stuff for this VPN connection. Yeah. So and then so typically what during the setup process you download a configuration file. That is from the customer side, specific to customer data, and and then you'll populate that in your VP virtual private gateway. So and you'll also provide the details about what should be your tunnel IP routes and other stuff. So these two also you'll configure. Basically, this guy should your VPN should know about your the customer's data and similarly other way around. So this guy should know about the AWS side data. So as long as those two are exchanged on the routers on both sides, the gateways on both sides, so that should be good for the data transfer to happen. So, and the typical advantages with the site to site is generally the they're generally highly available because it's managed by AWS. So you get the high availability aspect, typically with two tunnels, and also this also can support multi AZ option as well, where we can it can be this VPN tunnels can be in any region or any zone, for example, availability zone. It can be in any availability zone. Um, so yeah, so it supports multi-AZ support as well. So let's say you're growing and you want to add more support just to in US East 1A Virginia 1 location, you want to do in 1A location, 1B location, 1C location. So your data you have VPCs in all these regions, all the availability zones. VPN is supported by default connect. So again, that's all completely managed by AWS there. So again, this is secure and IPsec and the TLS tunnels are being used primarily for security aspect. Again, monitoring, it has robust monitoring, so where it can show you visibility in terms of the local and remote networking health, and also, we have to talk about two sides, right? So you should look at the health on both sides. If one is down, you should be getting some alert or something. So that all those monitoring stuff is all inbuilt using CloudWatch. Again, CloudWatch is only monitoring tool in AWS primarily. So everything is all monitorings are going to CloudWatch. So yeah, you can monitor all the stuff using this CloudWatch tool. And also this accelerated application. So this also there's something called accelerated site to VPN. This is not the common one, but let's say you want if, the data transfer between your on-premise and cloud should be very fast, you're super fast, for example. So then we have something called accelerated site to VPN. So this is more advanced feature where it provides very good performance compared to the normal ones because it internally uses AWS Global Accelerator. So AWS Global Accelerator is something like private link. It's like commonly used in all the products, but the concept of Global Accelerator is like it's all the networking which is very intelligent networking which is defined by AWS, which will primarily intelligently identify what is the nearest AWS network endpoint. You can intelligently identify that, and then so that way you get a better performance. So that is what is global accelerator is. That is it's used inside most of the products, but yeah, I think on the networking side. But yeah, accelerated site to site VPN internally uses this global accelerator product. So again, if there are any questions around what is the intelligent routing mechanism for in AWS to identify the nearest networking endpoint, answer is AWS Global Accelerator. So yeah, that's about the. Sorry, go ahead. Is there a question?
Is the AWS Global Accelerator is taken care by AWS? So as a user or as admin, you don't need to do anything about it?
Yeah, at least in this coming to site VPN, you don't need to do anything. It is something internal. It is just it is used inside, so you don't need to bother about accelerator. Yeah.
So it's transparent to you, so you don't need to configure. You don't need to worry about it.
Exactly. Yeah. Exactly. Yeah, it is something like a private link. I mean, we also saw similar product. Private link is used in other products, right? So but it's just you need to know that there is um, there is a there's an inside concept which is used, but as an end user, you need to know about it at least from this product point of view, site-to-site VPN point of view.
Okay.
Okay, so then looking at the use cases for site-to-site VPN, or I think we discussed this extending your corporate network into the cloud. So we saw that here, where you want to extend your on-premise setup, and you want to extend that data center to cloud. That's where this VPN plays a major role. So and then the secure communications between the remote locations. You want to do it. Imagine that this is another site from the same corporate. Imagine that way. So it is like you're extending the connection, a new site inside your existing site. So it's like an extended site for you. So so from your network you can connect to this extended network. So that is the site-to-site VPN stuff. Um, so the typical process, the flow is that in AWS site-to-site VPN, so you go to management console and probably you create a VPN connection to a transit gateway or a virtual private gateway. So I think we saw about virtual private gateway is what we saw here, which is a very common use case. But in this place, there will be also a transit gateway, which you'll see the following section. But it's more about more advanced concept. But this is generally we virtual private gateway is most commonly used category here. So on the AWS side, so typically when you want to create a VPN, site-to-site VPN, you first need to create a virtual private gateway or a transit gateway, and then you uh, generally you'll if you want to you need it's an optional component as we just discussed. This global accelerator site-to-site VPN is an optional component, but it comes with a cost, but it is an optional component. So if you want to enable that, you can enable that. Again, it's not mandatory. So if you want to enable, you can enable this optional component. And with that, you primarily download this configuration file from the console and input this file into your on-premise router. So that way, you're making connection details to your router in your on-premise, and then you establish the connection. Primarily, your device will then automatically on the customer side, the device will then automatically connect to your transit gateway or VPN gateway via site-to-site VPN. So again, the concept is same. You do the basic stuff, download stuff, and configure it in your on-premise site, and then you are good. That's all. So that's about the site-to-site VPN. So yeah. So again, this is something which I couldn't do a demo because it requires a lot of configuration. It's kind of an advanced setup, so it's like you need to have data center and other things. So it's all. I can quickly show you the screens again from exam point of view. It is important to know the concepts, so it will not be expected for you to make this connection or do this in practice. So it is not expected, but I can quickly show you how this screens will look like. So typically you go to VPC. So everything is for networking. Everything default is VPC. So you navigate from VPC generally. Uh, so under the VPN category, you have the site-to-site VPN. So uh, so again, before going to site-to-site VPN, as you saw in the PPT, so we have two things. Sorry, there are two things. One is the virtual private gateway and customer gateway. So these are two things that you need to create. So that is what these options are. So customer gateway and virtual private gateway, and followed by that site-to-site VPN, and the last one is the client VPN that we saw as the second option under the VPN category. So yeah, so typically either can directly first go to virtual private gateway because that's our first step, you typically create a virtual private gateway. So it is nothing much. So you just need to give a name and what should be your ASN Amazon site. So that you should, either you should Amazon default ASN or your custom ASN. So that is something on the networking side you need to know. Once you create that, then yeah, you go to site-to-site VPN connection, and now you create a VPN connection. Yeah, here you can give a name. So as I said, like, there are two options here. Either it could be a virtual private gateway or a transit gateway. These are the two options we have. So based on that, you need to select. This is very common. Virtual private gateway is most commonly used. So yeah, so whatever the gateway that you created in the previous screen, so that will populate here. And then on the customer side, again, this customer gateway, either you can use an existing gateway if you're already having it, or you can create a new one. If it is a new one, then you generally give the IP address on this customer gateway. What is our router's IP address here on this side? BGP, ASN, and if you want to have a set, like you want to encrypt the data and you already have an ARN, so which is like internally certificate management, for example. So this is again another very popular tool commonly used across products. AWS Certificate Manager, which is primarily a tool to manage your certificates, your public and private IP certificates. So that will be managed in ACM. But let's in case you have a private certificate for your domain and IP. So you generally give this ARN. Again, this is an optional component. Then yeah, so basically you're creating a customer gateway, and then yeah, the two options, the routing options are primarily dynamic and static. So these are the two options we have. Again, the significance of this concept is basically dynamic uses border gateway protocol. So it is like it is intelligently identify what should be the IP address on this side, and then it can auto detect all your IP ranges. We just provide IP range. That's all. So it will do the auto detection. But whereas static is like you need to configure what should be your rule for the source and destination. So it is like typically the routing, manual routing. So you create a route, then close it. So that's how this screen is. But other than that, if you want to have those security options, what should be the tunnel, the VPN tunnel that is going securely over the network? What should be the encryption methodology for that? So that is again, these are all optional. We're not providing if you see generated by Amazon. So this all will be generated by Amazon for you. Like what should be it's a lot of security options like pre-shared keys or for example the CAD. See if you know the inside CADR range, you can define that. All those tunneling options will be provided. What should be security for data transfer? So that will be provided by this tunneling option. Right. So it is very simple. In sense like it will just you just need to tell what is your VPN, virtual private gateway, and then you will tell what is your customer gateway. These are two things that you define. If you look at your virtual private gateway and customer gateway. So if you select existing, then it is just these two. So that's all. So yeah. So with that, you have um, uh, this VPN connection ready. So and then you can transfer data across the network. So that's about the site-to-site VPN. Uh, and then let's move on to the second topic, which is the client VPN. The client VPN is again it's a similar use case. I think if you remember this diagram, so it is using as an end user you want to talk to your AWS network. So and use a typical client, any open VPC client we can use. So this is what we generally use for most of our projects. So the advantage in this are primarily it is fully managed by AWS, where when I say fully managed, the deployment of this client VPN and the how much capacity to provision and service updates, if there are any software updates, all those stuff will be all for this VPN client VPN software will be all managed by AWS. Then Again, it also supports the advanced authentication, like multi-factor authentication or federated authentication. So all these advanced authentication levels are also enabled. Yep.
No, you were like your voice was not here for some time. So
Oh, is it?
that's why.
Oh, okay.
Yeah.
Okay. So where you in? I mean, I was just this advantage. I mean, where I stopped. I mean,
Yeah, it is started with this AWS VPN,
client VPN, right?
use
Ah,
cases,
okay.
but
Okay.
that's okay. I think, yeah, I just wanted to inform that.
Ah, okay. Okay. Fine, yeah. So yeah, this client VPN is again fully managed by AWS, so whereas where in terms of the deployment, capacity provision, and software update of this client VPN, everything is managed by AWS. So you don't need to bother about those upgrades and other stuff. So and also it supports multi-factor authentication and federated authentication. So which is like multi-factor is like a two-level authentication or three-level authentication apart from your RSA token or any other things. If you want to have an additional authentication, typically Google Authenticator is most commonly used as a second level authenticator. So similar to RSA tokens. So you can use all those stuff. And it is also federated authentication is primarily it has integration to your own on-premise Active Directory or it is all belong to your employee ID, right? So this client is an employee. So so this guy is an employee of a company. So he will already have some user ID and password details. So which is already integrated in their Active Directory or LDAP or any other system that is used in the on-premise. So it has integrations to all those internal stuff as well. So basically, you don't need to create a new user ID and password. So you can use this existing LAN ID and password, for example. So all integrations are all possible with this client VPN. And generally, again, this comes to elasticity. So where you can scale up and scale down. Let's say you are hiring temporary employees on contract, for example. So you can where they'll be working for a couple of months. So typically you can just since this is a cloud-based software, you can scale up your VPN counts, client VPN connections. When the scale when you want to ramp down, you can ramp down. So whereas in on-premise, it requires a lot of infrastructure. So if you want to use an on-premise VPN service, yeah, it is not an easy job. So, but whereas in cloud, you get all that scale up, scale down requirements very easily. And then the AWS client VPN, yeah, they also provide users to connect to AWS and on-premise networks using a single VPN connection. So you can talk to all the AWS products once they're connected via VPN connection. So, and yeah, very common use cases. If you look at you can quickly scale the remote access during unexpected events, allowing employees to work remotely. I mean, this is or Corona is a perfect example where most of the employees are working from home. So you want there is a point where you need to scale up all your VPN connections to let's say an employee is using a VPN connection to connect to cloud. Then they can this being a cloud software, they can quickly ramp up on the on this usage aspects. So that yeah, that is one big advantage that we have in using a client VPN from AWS. And also yeah, easily deploy and remove the VPN access for temporary workers. Yeah, I think we already discussed. So there are contract employees where you can ramp up, ramp down the connectivities very easily with just a button click. And also easily access applications in cloud and on-premise. Again, primarily during the cloud migration, this plays a major role where you want to transfer the data from your local laptop to or the server to the cloud, so via private connection. So you can do that very easily. Another very common use case is that's when you primarily also use VPN. Uh, and also like scenarios where user they don't have to change the way they access their applications during or after migration. Yeah, so it is so with VPN, it is an extended hardware, right? So you get an extended hardware, so you don't need, you can follow the all the practices that you're following in your on-premise. You don't need to reinvent or go to some new processes. I mean, you can just follow the process that you're following already because it's an extended network for you. So yeah, so the way you connect to VPN and the way you access your EC2, everything will remain the same. So yeah, it will not be a big change for your end user, for the employees actually. So that's where this VPN plays a very common use case there. So
Say, Shyam,
yeah,
in the case of a large distribution of or a large number of people want to be connected to the VPN client, like you said, remotely working consultant. So will the authentication be distributed by email or something like that, or they have to log into AWS and then download it?
yeah. I mean, there are a lot of AWS is supporting all the popular open source VPN clients. So you can use any open source VPN client that AWS supports. But generally, any enterprise will have their own listed approved softwares. So yeah, for you, you just need to know your user ID, password, and server IP details. These are three things that you need to know. That's all. So yeah, you can just download the client from internet, and then you can start using it.
Okay. Okay. Thank you.
Yeah. Okay. So this VPN client architecture, if you look at, I think it is just we saw. So as an end user, is trying to connect to some VPN client, and using that, he once he connects there, he will directly can access the AWS VPC subnet, and from there he can access all the other resources outside of this VPC as well. For example, other AWS services, or it could be another VPC, for example, via VPC peering. So, like as if he's there inside the public subnet. So, I mean, as if he's accessing, he's having access to the AWS console, whatever he can do everything. So yeah, so that's typically the architecture. So end user will talk to client, VPN client, and client will talk to subnet, and from there he can access all the other resources. And at this point, if you look at, there are two things where as a client, one authentication and authorization. These are two things at this point that they're doing. For example, here an employee is having user ID and password. So that user ID and password, it could most probably it could be LAN user ID and password, or it could be some other mechanisms which are there on premise. So generally, the authentication is done generally through Active Directory or any other mutual authentication softwares. And more like AWS supports most of the popular domains like Active Directory equivalents. So it supports everything. So yeah, so it every organization will have different authentication mechanisms, but most of them are supported by AWS. So that shouldn't be a problem. So basically, he don't need to generate a new user ID password. He can use his existing LAN connection details itself to connect to VPC. VPN. That is at this level, which is authentication. Once authentication is passed, then comes authorization in terms of uh, which networks this guy is having access to, and which security groups are applied. Security group, you saw that it is just a security rule that can be applied at instance level. Remember that previous slide. So this guy is having access to what and all. So that's called authorization. So what he can access in AWS. So that is automatically applied. So that way you don't have access to VPCs where you don't have access to, for example. So that way it is restricted. So that's a typical VPN client architecture. And yeah, generally it is AWS managed software, then secure access to any resources in AWS, and also and on-premise from anywhere, and using open VPN clients. So again, this OpenVPN client is like, this is like all popular open source VPN clients. That's what I mean, the OpenVPN client. So it supports all the popular open source VPN clients as well. It is not restricted to use Amazon's VPN. You can use any open source VPN softwares also. And similarly, it can integrate with your existing infrastructure. It can seamlessly integrate like your VPC, AWS directory services, and all those stuff. So it can integrate as well. So that's the concept of the VPN client that we're talking about.
Hey, Shyam.
Yep.
So probably a good time to stop your video once.
Okay. Yeah.
On the recording. Yeah. So meanwhile, as he is doing it, one interesting fact, after this corona, 30% of the companies are, not 30%,